So much of this is possible because of Bloom's taxonomy. And I'd like us to note that it's simply an increased sophistication of the learning goal that we already established. We're not leaving the learning goal, we're still just moving up Bloom's taxonomy. And we're working towards clarity of learning. While the courses that are assessed with percentages might simply give a student who has reached early proficiency 100%, this format, the design forces students to think deeply. Instead of allowing students to be rewarded for what we'll call repeated proficiency, their initiative and depth of knowledge is what's merited. They actually are moving along this continuum. And I would say repeated proficiency, that sounds like kind of like you have to be consistent, they have to be accurate, but that sounds pretty lame. I think it's motivating to hear like, oh, you need to go deeper. What's also cool is that you'll have a classroom dynamic where some students are driven for high marks. And when we get rid of high marks or percentages, they have no choice to go beyond and go deeper into their learning instead of the high marks. So do you want to prove that you can go beyond? You'll need to extend your learning aside from just these high marks. Let's continue to another unit of study. Here we can find not just a unit of study on rates, ratios, proportions, but one on the Pythagorean theorem. Here, this is taken from another learning continuum in the appendix. But here you'll note it says, I can apply the Pythagorean theorem to solve a variety of problems. This means that I can use the Pythagorean theorem at appropriate and useful times. This means that I can manipulate squares and square roots accurately. And this means I can show my math thinking clearly. In order to deepen my skills and understanding, I can, well, what should they do? We know that we have to move up on Bloom's taxonomy. And I know some teachers will push back on this because they feel like they're leaving the goal too much. I have to say that this is by far the best way for enrichment or to extend. So we're going to look at Bloom's analysis or even Bloom's synthesis. The Bloom's Taxonomy Teacher Planning Guide is a fantastic spot to look. You can look for verbs that students could use in the next level with the Pythagorean theorem, but I will also show you that they have questions that you can ask. So there are these keywords, but on the bottom of this PDF, you'll see this. Here are the questions. Questions that have to do with analysis, questions that have to do with synthesis, and we can use our content to formulate extensions and enrichment for students. So I could have students analyze or synthesize their knowledge of Bloom's taxonomy. Let me show you what I've done, and this was with a test. So let's move forward. I'll spoil the ending in a moment. So here's the top page of the test. And this is, I would say it's not as powerful as the diverging pathways for the ratios proportions unit that I shared, but it's still a fantastic way to articulate enrichment. So on the top of our test, we have our target and criteria. That's the only thing on the test. No point totals, no percentages. All I'm looking for is those pieces of success criteria that prove to me you can apply the Pythagorean theorem. But at the end of the test was like 4 questions long. There's a 5th question that looks like this. It says, I can examine non-perfect squares in detail. Examine. That's Bloom's analysis. And here it says, examine the visual below and articulate how it represents the square roots of 5 and 12. Non-perfect square roots require you to use analysis. It's beyond what we've been looking at with applying squares, square roots, in the Pythagorean theorem. When we start to dive deeper or give this opportunity, students can say, okay, I can't just repeat proficiency. I need to go deeper. So I'm going to try this question because I'm confident and competent with what feedback I've gotten from my teacher. So at the end of a test, a student can give this a try. Now, I will say that there's going to be some pushback here, and I know there will be because this is not as equitable as the previous iteration of enrichment. For instance, everyone is given the chance at one point to find out if they have reached proficiency early and if they will go into a deeper enrichment or extension, or to go with the prescribed learning outcome or the final destination goal. With a test, You have to finish the test, or in this situation, before you get to this question. And that requires to have a lot of time. So you might need to find ways to make sure that everyone has enough time to see if they've reached proficiency early to try this question, or feel if they have enough confidence or competence to reach this question. So, what I would say is most important, though, is that you are articulating enrichment. I understand that some people might not love this version of it, but I think having an articulate way of saying, like, this is how we are enriching understanding, this is how my students can go deeper here. They're not just getting 100% for repeating proficiency, it's right here on the page. And that's a really cool thing. So here's how you might see our learning continuum. And on the next slide, I will show you a student-friendly version. Here you'll also see that it's phrased in questions. So it says, can you make a distinction between perfect and non-perfect square roots? Could you use a visual to do so? Can you invent a formula that calculates the Pythagorean theorem in 3D space? Both of those are upper level thinking, and both of those are open-ended questions that students could start to wrestle with once they've reached proficiency. And here's a learning map where students would have access to this ahead of time. I have one final version of enrichment to show you, and this is increasing complexity and content, and hopefully continuing to add to what we've talked about with clarity. This is well, you could call it a continuum of a sort for solving equations. So in 8th grade, we have to solve two-step equations with integers. A colleague and I realized that we had already done fraction operations and saw algebra to be an opportunity to spiral back to our knowledge of fractions. So we set a learning goal of being able to solve two-step equations with integers and fractions. You'll notice that's smack dab in the middle, level 3. We could move backwards and say, well, before you can do it with fractions, you have to be able to do it with negative and positive integers, hence level 2. And before you could solve a two-step equation, you have to be able to solve a one-step equation, hence level 1. What this did is it set our goal very clearly. We told the students that level 3 is where we expect them to be. This is what you need to do to finish 8th grade mathematics. This is what it means to be proficient. We told them, okay, here's an example of level 2 and level 1, and you need to start with what is easiest and move forward. But when we set consecutive levels, such as 4 and 5, students felt motivated to try new and hard tasks. So we introduced the distributive property. Well, I guess it had already been introduced in grade 6, but we showed them with unknowns. And we also showed them that you can combine like terms. And I know some people might be pushing back saying, this is the next pages of the textbook. You're just teaching 9th grade algebra. But what this did, it just continued to increase the complexity of the content. For this situation, it worked. So students were constantly seeing what level are they at? How do they try for something new? Mr. Dueck, teach me how to do level 4 again. Or that guy knows, that student knows how to do that. Hey, could you show me how I do? I want to get to the next level. And this would move them over and over past proficiency, which was a really cool thing. You could give the students a learning map that would look a little bit different than this, especially if you don't like the words levels. Here it could say, first I need to solve one-step equations. Then I can solve two-step equations. This is what I must do, two-step equations with integers and fractions. After, I could try equations with the distributive property. Next, this is what I could do, equations with x on both sides, combining like terms. Altogether, you begin to start to push students forward and motivate them to whatever level it is that they need to do. And also students realize they never try a question that's too hard because they're like, you know what, Mr. Dueck, I'm still struggling with two-step equations. I'm not going to try it with fractions yet. Instead of giving a kid a worksheet that has all of these and not differentiated. So everything is clearer and our extensions become accessible. And it also becomes simultaneous. Some students are at level 4, some are at level 2, and the teacher gets to continue to facilitate all the learning in the room. In sum, teachers are called to differentiate instruction, what a lofty task, such that students can extend beyond the prescribed learning goal. Rich tasks are a fantastic tool for including extension in daily lessons. Extension must be a deeper form of learning and not simply more of the same work. Enrichment is meant to move learning forward. If students realize that enrichment is simply about doing work for extra credit, their initiative will dwindle. Articulating criteria for enriched exploration allows teachers to have a clear vision of how students can engage in deeper learning. Articulating criteria for enrichment can take the form of I can targets or questions. Bloom's taxonomy can help teachers identify verbs for enriched targets or for extension questions. Clarifying enrichment forces keen students to engage with deeper sophistication rather than repeating proficiency. Allowing students to engage in enrichment earlier in the learning provides more equitable opportunity for students who have reached proficiency early to engage in more challenging and complex targets. Clarity of goals is key for defining proficiency, and the same goes for enriching understanding. Moving forward, I have my learning continuum, but I'm struggling how to remove percentages from assessment and gradebooks. That's the next session. I'm so excited for it. What should reports look like if the focus is simply assessing whether students can accomplish goals? We will also look at reports in the next section. This is so theoretical. Do you have any more hands-on tips? Follow me to the next session. But first, it's time for your turn. Refer to your session handout for discussion questions and tasks, for reflection on your own practice, discussion with your peers, or enrichment for those of you that feel like you understand this already. Notice how I've been doing enrichment the whole time? Look at that. If you feel the need. You can choose which one you want to do. You don't have to do all of them. And then finally, suggested reading. Here you'll find these are some fantastic readings and my references for today's session. I will see you in our final session. Thank you for joining me.